Today we're going to be looking at, for this exam wrapper, question 1 from the first test, which involved a pelican entering the water under given conditions and the Python code needed to model that. Shown here is the code that was provided on the exam, as well as some of the initial conditions that were provided, such as the initial velocity of 15 meters per second when the pelican enters the water, the angle of 20 degrees that it does enter the water, and the ratio of the drag force to velocity, which in this case the drag force was proportional to velocity cubed. The triangle shown breaks up the components of the initial velocity for the horizontal and vertical component. Shown now is the completed code, and we will go through each step and explain what it does. First is the pelican's velocity, initial velocity, which is set equal to the vector using the components, the x and y components shown in the triangle on the last slide. That's derived using the angle with the initial velocity. R hat is the direction vector. For this we're using a built-in function of Python norm, which will find the difference between the two vectors. W, this is going to be the force of gravity. In this case, or in all cases, it's the pelican's mass times the constant, gravitational constant, acceleration of gravity, rather, multiplied by r hat. R hat is really important here because that gives you the direction of the force at that time, where the direction of certain forces may change throughout the loop. The drag force is modeled by, it's proportional to velocity cubed, so as you see, velocity is multiplied. The pelican's velocity at that instance is multiplied by itself 3 times, as well as the proportionality constant b, which was specified in the code provided, as well as the direction vector, once again, as that changes for the iterations of the loop. The net force then is the force of gravity added to the force of drag. They will have opposite signs, so actually the final product would be the force of gravity in essence minus the absolute value of the drag force. The pelican's velocity, new velocity for each iteration, is equal, using Newton's second law, is the initial velocity summed together with F net over m multiplied by delta t. This is just basic Newton's second law written out in Python code given the variables. The position is done pretty much exactly the same way. You take the initial position for that iteration to find the final position for that iteration by taking the instantaneous velocity and multiplying by the change in time, which was specified in the problem. And that is it. That is the complete work for question 1 on the first exam.